Computer wasn't letting me pull up the quiz.
All right, we're on.
Okay, you want to just start with number 3?
Sure. All right, number 3. Let's see. All right. In a pie chart, why are the slices or sectors different sizes? And it's because each slice represents a category, and the area of each slice represents the proportion of the total occupied by the category.
Yes. That was the third one there, right? Yep. Number 4, how are bar charts and Pareto charts related? The only difference between a bar chart and a Pareto chart is that the bars in a Pareto chart are ordered largest to smallest going left to right.
Yep. All right. So we conclude that P hat is normally distributed if the sample is greater than 10, or sorry.
Mm-hmm.
Yeah,
that's right.
Greater than 10.
Greater than or equal to.
Mm-hmm. Yeah. And then the sample times 1 minus P proportion is greater or equal than 10. Yes. So is P the true proportion or the sample proportion? And it is the true proportion because P hat is the sample proportion.
Right. Yep. And then what is N? N is the sample size.
All right. If P equals 1/4, what is the smallest sample that satisfies the requirement? And it's 40.
Mm-hmm. Yep. Because if you plug 40 into the N times P is greater than or equal to 10, 40 would be equal to 10. Number 8. Suppose the sample size is 24 and the proportion of the population is 0.4. What is the mean of the sample proportion? And the mean is the same as the population proportion. So it'd be 0.4.
Yep. All right. So number 9, the standard deviation. So if you plug 0.4 into that, well, yeah, if you do the standard deviation formula, it comes up with 0.1.
Yep. Number 10. We're trying to find P hat, which is basically the proportion of our test. So it'd be 35 hits out of 100, it'd be 0.35.
Mm-hmm. All right, then the standard deviation of P hat is 0.046.
And then the z-score is found by taking the sample population minus sample proportion minus the population proportion over the standard deviation of the sample population. So for number 12, that would be 1.087. Is that what you got?
Let's see. Number was that one?
It's number 12.
Oh, okay. Yeah, so I got 1.091 just because I put it in a scientific calculator. Like, all the decimal points.
Oh.
You know what I mean? Because yeah, it was right. Like 1.091 was right.
Okay.
So because so I put in all the like I rounded it. Like I rounded the
1.091.
Yeah. So if you take, so let me see my notes here.
Yeah, I took 0.35, which is the sample population or sample proportion.
Yeah. Minus 0.3.
0.3, so you give you 0.05.
Divided
by the standard deviation, which we just found was 0.046.
Yeah.
And
so then you get that, and it gives you a whole long number, right?
Mm-hmm.
Right. So if you take that whole long number, and then get the z-score from that. So if you use that long number for
well, if I round to 3 decimal places, it's 0.087.
Yeah, no, I know. So okay, so let's see. So the z-score is, let's see. What did I do? I did something different. I'm trying to think. I can't remember what I did.
Yeah, that should be the z-score.
Let's see. So if you take, let me see here. Okay, so on
Three times 0.7.
Okay, so when you figured this standard deviation, right?
Oh, I see.
So when you figured the standard deviation, you rounded it, right? So instead of rounding, like, so that's obviously the answer for the standard deviation. But then when you do the next step, you don't round it. You just leave the whole number.
Okay.
Like on a scientific calculator. And that's how you get, then that answer is 1 point.
Okay.
Do you understand?
I think so, yeah.
So like, yeah, so your standard deviation comes out as 0.046, right? But it's actually not 0.046. The 0.046 is rounded 3 decimal places.
Right.
So if you put the whole number you get for the standard deviation, which was 0.0459, blah, 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 you know, and you take that number and plug it into the scientific calculator for when you're doing the z-score.
Right. Okay. Yeah, that makes sense.
Yeah. So then it gives you a little bit different number.
I'm just gonna plug it in real quick. Okay. Yep. I just put it in Excel and it's 0.091.
Yeah.
All right.
So and I put that in and it was right. So
yeah, I actually got that one wrong, but I thought I got it wrong because I actually mixed up the p hat and the p, so I did negative. So I got it.
So anyway, yeah. So that's on. Because I remember I got that first, and I was thinking about it. I'm like, wait, that z-score was, or the p hat, or the standard deviation was a long number. So if I put that in, does it make it different? And it actually did make it different. So
it did. Yeah.
Anyway,
okay,
kind of
that's
stupid.
Good to know. Yeah.
All right. So question 13. What is the probability that Brittany gets at least 35 hits in her next 100 at bats? Her next 100 at bats. And if you plug that into the normal, plug 1.091 in the normal probability app and shade the right-hand side. you get 0.138.
Okay. Yep, it was a little bit off.
Yeah. Yeah, that's what, it throws everything off.
Uh-huh.
That one answer.
Right.
Yeah.
Okay. All right. Let's see. We're on number 14.
Yeah.
Okay. Let's see here. So we're giving a political candidate. The population proportion is 0.52. Sample size 2,000. We're trying to determine the probability that the results of the survey will suggest the candidate is losing the election, has less than 50% of the votes. What is the standard deviation of the sample proportion? And I got, when you put it in the formula, you got 0.011.
Mm-hmm. All right. So, question 15, the z-score is negative 1.79.
I got negative 1.818.
Oh, really?
Yeah.
Hmm.
Yeah, and I know I got that one right.
I got it right too.
Oh,
So
really?
maybe it gives you, yeah.
Because it says to round to 3 decimal places.
Yeah.
Huh. Maybe because you did the same thing, right? Where you typed it into a scientific calculator.
Yeah.
I wonder if it's the same thing going on.
I don't know. Whatever. I wonder if he just gives you a little bit of leeway or something. I don't know.
Yeah. I'm wondering that too.
Huh. Oh, well.
And you just did, what was it again? Negative 1.79?
1.79. Yeah.
Huh. That's weird. I wonder if I left, if I did, instead did positive. I bet it would give it to me. Anyway, I'm going to keep it though.
Sorry.
That's all right.
Yeah.
Last question. We want to know the probability. The survey results will show that the candidate is losing, even though the true population proportion is 0.52, and that probability is 0.035. You get something different?
I got 0.037.
Yeah, there must be a little leeway then, because I got that one right as well. That's strange. Huh.
That's really weird. Oh well. Huh. But you did get the one wrong, though? Number 13. Or which was it?
So, yeah, so I got 12 and 13 wrong because I got 13 wrong because I just did the wrong side of the because I did negative. Right. Yeah. Mm-hmm. So I did the wrong side of the probability curve.
I wouldn't try it, but I guarantee that it probably gives us leeway on that one too.
Yeah, I'm positive it would. I didn't try it, but I left the 15 and 16 correct or the same.
Yeah,
and it gave me those points.
Huh. So, interesting.
That is weird. Huh.
All right.
Well, we need to talk about the project, huh?
We can. When do we have to have it? Did you look? When is it due by?
I think it's soon. Let's see here. I was looking over it last week. So it looks like there's a design the study self-report quiz. What is this? There's 5 attempts.
It says it ends March.
Okay, so it says, purpose of the quiz is to ensure that you have taken the necessary steps to submit an IRB, should your study require to do so. You may take the quiz multiple times as you go through the IRB approval process.
Okay. So it looks like we just have to have one submitted by the end of the week.
Yeah. They were making me nervous with like, they're like, it's really hard to come up with a study. I'm like, okay. You got any ideas or?
I don't. That's what I was saying. Let's look into it. I gotta look into it more.
Yeah, I was one that I had kind of like thought about. I don't think it'll work, but I mean, I was just trying to like because they've already given us like a bunch of um, like sample studies in our just like the where they give us the data. And so one of the ones that I was thinking of was where they gave us the data for like the prices of Hummers in two
Yeah.
different states. And so I was thinking we could do something like that, but for maybe a different product. And then we would, because where are you at? You're in
Arizona.
Arizona. Okay. I'm in Colorado. So I don't know if that's too simple, if that's going to fly, but I was thinking like prices of beef or something. Or
why not? I mean,
prices of Easter candy or something like that. I don't know. But I don't know if that'll fly, if that's too simple. But basically, we'd be taking the same kind of format.
Yeah.
So it'd be a T-paired sample with independent variables.
So yeah, the paired, T-paired.
Mm-hmm.
Let's try it. Let's try to submit something.
Okay. Do we want to go with Easter candy or?
Yeah, might as well.
Because I mean, well, what they were saying, the difficult part was to get a truly random sample. So that's what they were saying. Like, you got to be careful because it's not just picking names out of a hat. So I'm like, then what is it? Like, don't tell us what it's not. So I don't know if we just go to stores and just pick some random candies or.
Yeah.
Like,
let's try it. I mean, let's submit. Should we just try submitting that, or do you want to submit that and see what he says?
Yeah, we can try it.
The quiz. Okay.
Yeah, I'll do that, and if they tell us no, then we'll try to find something else. But
all right, cool.
With that.
All
right. We will see you on Wednesday.
All right, cool.
Bye.
Have a good night. Bye.